All right, now we're recording. Okay, so good deal. Thank you. So then the cosine of our angle, guys, is going to be what over the hypotenuse? Anybody remember? The adjacent. Excellent. And then the tangent of our angle. Anybody know how we define the tangent of the angle again? Something over something else. Opposite over adjacent, right? Perfect. Okay. So, so look what we're doing here, guys. We're going to be looking at 30 degrees, 45 degrees, 60 degrees. And I know I've mentioned this before, and some of you said degrees, and I think somebody said radians, but to me, it's much easier for me to understand these trig functions in terms of degrees because we know numbers like 30 and 45 and 60. We know numbers like that, and it's sometimes a little difficult to like, what's 7 pi over 6 or something like that. It's a little hard to understand at times. So I just feel, personally, I feel more comfortable using degrees, so that's what I'm going to do. Whoop. What happened there? And are we still sharing? Yeah, we is. Okay, so sine of 30 degrees. Remember how we defined the sine? It is the opposite over the hypotenuse. So if here's my 30 degrees, what's the side opposite? Over 1/2, right? 45 degrees is the opposite over the hypotenuse, which is 1 over the square root of 2. And then if you remember, guys, we would rationalize our denominator by multiplying the top and the bottom by the square root of 2. So when I go straight across, that's going to give me the square root of 2 over the square root of 4. We don't know the square root of 2, but we do know the square root of 4. What's the square root of 4? 2. Okay. And then 60 degrees. So we're going to say, okay, now I'm looking at 60 degrees. So the opposite side is square root of 3, and the hypotenuse is 2, right? Okay, and then we're going to do the same thing for the cosine, okay? So we're going to come back here, we're going to do the cosine. So again, look what we're looking at. We're looking at the cosine of 30 degrees. Remember how we defined cosine? We said cosine was the adjacent over the hypotenuse. So this one here was the square root of 3 over 2. The cosine of 45 degrees was the adjacent over the hypotenuse. We did that earlier, didn't we? And we came up with square root of 2 over 2. And then what would the cosine of 60 degrees, Bill? What would the cosine of 60 be? So remember how we define cosine? The adjacent over the hypotenuse. So here's 60 degrees. What is the side adjacent? 1, right? Over 2, 1/2. Okay? And so remember, if you remember this from the notes, guys, or from the video that I made when we had this, wherever this came from, we said the reason why it's 1, 2, 3, and this is 3, 2, 1 is because 1, 2, 3, 3, 2, 1, right? They kind of, it's going to be the same thing, just going in the opposite order. All right. So knowing those values is going to help me figure out the sine and cosine, tangent, secant, cosecant, cotangent for all these other angles, okay? So we have these things called reference angles. So when our angle is between 0 and 90 degrees, it's just the angle itself. We've already done those. We don't need to worry about that. But when our angle is in quadrant 2, okay, when our angle is in quadrant 2, the way I find my reference angle is going to be 180 minus whatever my angle happens to be. If we are in quadrant 3, the way we're going to find our reference angle is we're going to take whatever angle we have, and we're going to subtract 180, right? And then whenever we're in quadrant 4, the way we're going to find our reference angle is we're going to take 360 degrees minus whatever angle we have, okay? And these are the reference angles that we're looking at. So guys, what we're ending up with here, we're ending up with little triangles, right? Okay. In quadrant 2, do you remember what coordinates are positive and what coordinates are negative? In quadrant 2, so we're on that side, upper left-hand corner. Is the x value positive or negative in quadrant 2? Negative. But the y value is positive, right? In quadrant 3, which values are positive or negative? They're both negative, right? Okay, and in quadrant 4, x is positive and y is negative, right? And in quadrant 1, we already know this, but they're both what? They're both positive, okay? So the reason why I'm bringing that up, And notice what we have here, guys. We have 30, 45, 60, and we have them filled out for sines, cosines, right? The 6 trig functions. So what we're going to do now is we're going to figure out how do we do this when we have these other values, okay? So the first thing I'm going to do here, I'm going to draw a picture, okay? So here is my picture. Here's my x, here's my y, and I'm going to draw 120 degrees, okay? So this right here, y'all, indicates 120 degrees. What quadrant are we in right now? Look at my angle. Look at where we are. We're in quadrant 2, right? We're in quadrant 2. Okay. That's okay. You're good. Here's my 90-degree angle. Here's my right triangle, right? Remember, when we're finding the reference angle, y'all, it's always going to be measuring from the x-axis, okay? So what we need to figure out is, what is this angle theta prime do? How are we going to find that, right? So yeah, we would do 180 minus 120. That would give me 60 degrees, right? Okay, so look, I'm just going to clean this up a little bit, come back here. We know this is 60 degrees, so we know that's 30 degrees, right? And if I come back and I take a look at the picture that we had before, what was it? Somewhere over here. Okay, let me just kind of clean this up because I'm coming back to reference these pictures. Okay, the side opposite of 60 is the square root of 3. The side opposite of 30 is 1, and the hypotenuse is 2. So this side over here, y'all, is going to be the square root of 3. This side over here, because I'm in quadrant 2, I'm going to think of that as a negative 1 because the x value is negative in quadrant 2, and our hypotenuse happens to be 2. So now we're really using the idea of the 60-degree mark, right? So the sine of 60, the sine is the opposite over the hypotenuse. Isn't it still the square root of 3 over 2? Okay. Now the cosine of 60 degrees is the adjacent over the hypotenuse. Isn't that negative 1/2? Okay. And the tangent of 60 degrees is going to be the opposite over the adjacent. So square root of 3 over negative 1 would be a negative square root of 3, right? Okay. So now that we have those, then we should be able to find the cosecant, secant, and cotangent, right? So let's take a look here. The cosecant isn't that just the reciprocal of this guy? And didn't we already have that right here? So that's still going to be 2 square root of 3 over 3, right? And then the secant is just the reciprocal of this one. So the reciprocal of negative 1/2 would be a, that's right. And the cotangent here is just a reciprocal of this one. So if this is the square root of 3 over 3, but here we have a negative, wouldn't we just put a, does that make sense on how I'm doing this? Okay, so guys, remember we said we're in quadrant 2. What value is negative in quadrant 2? The x. Okay, so one thing I'm going to put up here, y'all, I'm going to go like this. Sine of my angle, y over r. Cosine of my angle, x over r. Tangent of my angle, y over x. Cosecant of my angle is going to be r over y. Secant of my angle is r over x. And cotangent of my angle would be x over y, right? And that's kind of how we defined our trig functions early in chapter 4. The reason why I'm doing that is I want to, if I know what, all I'm really doing, y'all, is I'm coming back to reference these back right here. Nothing is going to change. The values are going to be the same. What's going to change? The signs. What I mean by the sign, not the sign as in this sign, but whether it's positive or negative. Does that make sense? Okay. So now we've done that one. Let's do 135 degrees. So look, I'm going to draw another picture here. Okay, and we're going to go like this. Okay, so here is 135 degrees. Do y'all remember how we're going to find our theta prime, our reference angle? Same way we did before. We're going to take what? 180 minus 135. So that angle down there, y'all, is 45 degrees, right? So look, we're going to go 45. We're going to go 45. Here's our 90. So this is 1, but since I'm in quadrant 2, this is going to be a -1. That's the square root of 2, right? Okay. So we're still in quadrant 2. What's negative in quadrant 2? Only the x. Sine does not involve the x, so this is still going to be square root of 2 over 2, right? Because the sine only involves the y, and so I'm really doing it for 45 degrees, but all I'm doing is I'm saying since it's exactly the same and my y, oops, I don't know what that keeps happening, I'm hitting something, and my y is positive, it's going to stay positive. The only thing that's going to happen to this one is now it's going to become a negative square root of 2 over 2, right? Tangent is going to become a -1, right? Because remember, tangent is opposite over adjacent, so 1 over -1, okay? Let's see, cosecant will still be square root of 2. What would the secant be? Negative square root of 2. And what would the cotangent be? -1. Are we doing okay so far, y'all? We're good? Okay, just checking with you guys. All right, let's do the same thing for 150 degrees. So I'm going to draw another triangle. And I know this is a little cumbersome, guys, but it's going to make the next part we're going to do, it's going to make 5.2, hopefully a little bit more easy breezy cover girl today. Okay, so look, here's 150 degrees. So if this is 150, everybody agree this is going to be 30? So this is 1, this is 60, this is a negative square root of 3, and that's 2. Okay. And I want to bring this down a little bit because I'm using 30 degrees, and 30 degrees was that top one we had there. So the sine is still going to stay the same. This is still going to be a 1/2. This should now be a, very good. And this one should also be a, good. And this should still be a 2. And this should now be a negative 2 square roots of 3 over 3. Good. And this one here should be a, and you got it, my friends. Better? Right? And we're going to, and guys, all we're going to do, we're going to play this game. We're going to do this, I think 6 more times, and then we'll be done, okay? So look, I'm going to clean up some of this mess because we don't really need all of this. And we're going to just keep doing the same thing we've been doing so far. So hold on, let's go slow, right? We're going to go slow. We're going to draw a picture again. Now we're looking at 210 degrees, right? Okay, so 210 degrees would be something like this. Okay. And what we're looking at is we're looking at this angle right here. So remember how we're going to find this one. We're going to take 210 and we're going to subtract 180. Okay, that's going to give me, okay, so this piece here is 30. This piece here is 60. Here's my 90 degrees. So this is -1. This is -3. That's a +2. Now we're in quadrant 3, right? In quadrant 3, didn't we say both x and y are negative, right? Okay, so look what angle I'm using. I'm using 30 degrees. So I'm going to take these values here, and I'm just going to start changing signs. So what should we get for the sine of 210? So remember what's the sine of 210? It's opposite over hypotenuse. What would it be? -1/2. Okay, what about the cosine? Negative square root of 3 over 2, right? Adjacent over the hypotenuse. Okay. Guys, let's do the tangent. Remember what the tangent is. The tangent is the opposite over the adjacent. A negative divided by a negative is a positive. So it's going to be the same thing we had here. Square root of 3 over 3. Okay. Cosecant is going to be a -2. Secant is going to be a -2 square root of 3 over 3. What do you think the cotangent is going to be? Square root of 3, right? Good. And you got it, right? So again, I'm doing the same thing that we've been doing before, guys. We're using the definition of what sine, cosine, right? We're using those definitions, but the values are going to be the same values we have here. The only thing that's changing are the signs of those values, right? Okay, so let's try another one. Let's try 225 degrees. So look, I'm going to draw my picture again, right? 225 degrees is going to be something like this. Anybody know what this angle is going to be? 45, right? So that's 45, and then that's 45. Here's my 90. Remember, these are both negative ones, and this is now square root of 2, right? Okay. So sine, we're looking at 45. If it's square root of 2 over 2, what is it going to be now? Negative square root of 2 over 2, right? Same thing for cosine. Tangent is the opposite over the adjacent. Negative 1 divided by negative 1, positive, right? And then I'm just going to look at these right here, and I'm going to say, look, it's going to be a negative square root of 2, and another negative square root of 2, and that one's going to stay the same. Javier, am I doing all right? Okay, just checking with you guys. All right, so guys, I'm going to draw one more triangle here. So let's go like this. Boom. And now we're looking at 240 degrees. So 240 degrees is going to be something like this. And let me make my picture a little bit better. Okay, so here's 240 degrees. So we're going to say 240 minus 180. Anyone know? 60. So this side is 60. This side is 30. That's a negative 1. That's a negative square root of 3. That's going to give me a 2. Okay. All right. Okay, so I'm using the 60-degree one again. Negative square root of 3 over 2. Negative 1/2. What do you think tangent's going to be? Square root of 3, perfect. Cosecant's going to be a negative 2 square root of 3 over 3. Good. This in here should be a negative 2 and positive square root of 3 over 3, right? Okay. Alrighty. And we're going to do, we got 3 more to go, guys, and we'll be done with this. Okay. So I'm going to zoom out a little bit because I do want to be able to see all my angles that we have. Okay, so now let's draw another picture. What angle we're looking at now? We're looking at 300 degrees. So 300 degrees is going to be somewhere over here. Okay. Okay, so remember, guys, our reference angle is always going to be with the x-axis. So my reference angle here, theta prime, is going to be 360 minus what angle are we looking at? 360 degrees. So this angle here is 60 degrees. That's 60, that's 30, so this is a positive 1, that's a negative square root of 3, and that's a 2, okay? So we're looking at 60 degrees. Here is the sine of 60 degrees, so it should be a negative square root of 3 over 2. Okay. Cosine should be 1/2, right? Because it's the adjacent over the hypotenuse. And remember, we're in quadrant 4 right now, so the only value that's negative in quadrant 4 is the y value. So if my trig function does not involve the y value, then my trig function is going to stay the same, right? This one here should be a negative square root of 3. This one here should be a negative 2 square roots of 3 over 3. This one here should be a positive 2. And this one here should be a negative square root of 3 over 3. Let's draw another picture. Now we're looking at 315 degrees. So wouldn't my angle here be 45? Okay. And so this side's a positive one, this side's a negative one, and this side over here is a square root of 2. So we're looking at 45. So this here should be a negative square root of 2 over 2. This one should be a positive square root of 2 over 2. This one should be a negative 1. What about the cosecant? Negative, right? Good. Negative square root of 2. This is a positive square root of 2. And still a negative 1. Awesome, awesome. Okay. And we got one more. We got 330 degrees. So here's 330 degrees over here. Okay. So wouldn't that angle be 30? That's 60. So this here is a negative 1. This is a square root of 3, and that's a 2. Okay. So I'm using 30 degrees, right? I'm using this first column up here, y'all. So the sine should be a negative 1/2. Cosine is still square root of 3 over 2. Let's see, the tangent should be a negative square root of 3 over 3. Cosecant is a negative 2. Secant should be, there you go, you got it. And then cotangent is a negative square root of 3. Okay. All right. So I wanted us to go through that there so that we know how we can find the sines and cosines of all these different angles that you might have, right? And the reason why I want to do that, y'all, I'm going to try to see if I can zoom in this as much as I can. Let me get rid of that. Okay. And then what I want to do is, let's see if we can do a little copy and paste. Copy that. Okay. And what I'm going to do now is, let's see. Let's go ahead and come back to where we were. And let's get started on 5.2. And we can print this thing. Let's print it. There we go. 1 now. That's where we want it to go. And right here, the same piece. Okay. All right. So 5.2, y'all, is the sum and difference formulas, okay? So we have some formulas dealing with the sum and the difference of our trig functions. So we have the sum of two angles u plus v. We have the sine of two angles u minus v. Same thing for cosine, and the same thing for tangent. Okay, so the reason why I wanted us to go through this business here is I want you to look at the first problem. The first problem here says use either an addition or subtraction formula to find the exact value. Okay, so guys, what we mean by that is we know the trig functions of particular angles. We know what they are for, I don't know if it's going to let me erase that because I copied it. It's okay. We know the trig functions for like 30, 45, 60, things like that. Is there a way we can come up with 15 degrees using either 30, 45, or 60? Whether we add or subtract. Meaning, can you come up with the number 15 by either adding or subtracting 30, 45, or 60? How would you do it? Okay, so we're going to do this. We're going to say this is the sine of 45 minus 30, right? So I want you to notice what formula we're going to use. We're going to use the difference formula because we are taking a difference right here. So in this case, y'all, this is my u, and that is my v. So the first thing we're going to say is we're going to say the sine of u, the sine of 45, times the cosine of v, the cosine of 30, minus the cosine of u, the cosine of 45, times the sine of v, the sine of 30, okay? And then what we're going to do is we're going to come back over here and we're going to reference these values, right? So what's the sine of 45 degrees? Square root of 2 over 2, perfect. Cosine of 30 degrees is square root of 3 over 2, right? Yeah, cosine 45, sine 30, right? Okay, minus, what's the cosine of 45 degrees? Square root of 2 over 2. What is the sine of 30? 1/2. Okay, before I go on, are we okay in how we got to where we are? Yeah, you sure? Okay. All right, let's do this. What's the square root of 2 times the square root of 3? Square root of 6 over 4 minus square root of 2 times 1? Square root of 2 over. Okay. So then our final answer, y'all, just to write it as one fraction, since we already got a common denominator, it's the square root of 6 minus the square root of 2 all over 4. And we found what's called the exact answer, right? So the idea here is we're going to use this table to see if we can find these special values. And if you notice what it's asking me to do, it's asking me to find, I'm going to zoom back out over here, guys, real quick. It's asking me to find the exact value, right? So if I were to grab my calculator, right, and I were to turn this thing on, and I want to make sure that I'm in degrees, because that's what we're dealing with. So let me scroll down here and go over to degrees. And I were to say, okay, what's the sine of 15? It's going to give me that. And that's not an exact value. That's a decimal approximation, right? The exact value that they're looking for is this piece right here. We'd come out to that same number, yeah. So look, we came up with what, 0.2588? So if I were to do this, if I were to say, what's the square root of 6 minus the square root of 2, and take all that and divide it by 4, we should come up with the same thing, right? But the exact value is that kind of funky looking expression, right? That's what we call the exact value. All right. Okay, so let's see if we can do the same thing for the next one. Look what we have here. We have the cosine of 7 pi over 12. So if I were sitting where you're sitting, this is the first thing I would do. I'd come over here and I'd say, okay, you know what? What is 7 pi over 12 in degrees? Anybody remember how to convert radians to degrees? What do I got to multiply by? 180 over pi, right? Think about it this way, guys. We want to get rid of the pi. And in this expression, the pi part is on top. So when we're going to convert it to degrees, the pi part needs to be on the bottom, right? And 180 degrees on the top. So what I would do is I'd say, look, let me get rid of this and let me get rid of that. And 12 goes into 180. Oh, I don't know. 180 divided by 12. 15 times, okay. And then, what's 7 times 15? Oh, 105. Okay, so then what I would do is I'd say, okay, really what I'm trying to find here is the cosine of 105 degrees. Just like we did before, is there a way that we can come up with the number 105 using 30, 45, and 60? What do you think? How can we come up with 40 or 105 using 30, 45, or 60, or a combination of those? I'm sorry, which one? Remember, we want to get 105. Let's see if we can do it using these. Can we come up with 105 using those? What do you think? How would you come up with 105 using either 30, 45, or 60? Anybody know? 60 plus 45. Thank you so much. Oh, you got me worried there. 60 plus 45. Okay. So what are we going to do? We're going to use that formula right there. Okay. So let's do it like this. Remember, guys, this is my u, this is my v. So I'm going to say cosine 60, cosine of 45 minus sine of 60 and sine of 45. Okay. And again, all I'm doing here is I'm just using the rule that we got up there, right? Okay, cosine of 60. Cosine of 60 should be 1/2 cosine of 45 square root of 2 over 2 minus sine of 60 is square root of 3 over 2, and sine of 45 is square root of 2 over 2. Okay, so let's go ahead, and this is supposed to be a 3. Let's go ahead and put these together. So that's the square root of 2 over 4 minus square root of 6 over 4. So again, here is my final answer. Easy breezy cover girl, right? And all I got to do is just use my formulas. Right? So guys, the formulas are there. All you really got to do is, how do I apply it? And again, for the most part, you want to see if you can go ahead and use the values that were given, right? So let's see. Let's do another one similar to this. It's the tangent of 75 degrees. Okay, we're going to play the same game we just played. How can I come up with 75 using 30, 45, or 60? 45 and 30 together, right? Okay, now guys, does it matter which one I put first or which one I put second? No, because when you add, you know, it didn't make a difference which ones you add, right? So if we go like this is the same thing as the tangent of 45 plus 30. Then what we're using is that formula right there, right? This is my u, that is my v. Okay, so I'm going to write it out. Tangent of u, tangent of 45, plus tangent of v, which is 30, minus, over 1 minus tangent of 45 times the tangent of 30. So tangent of 45 was 1. Tangent of 30 is square root of 3 over 3. Okay. All over 1 minus tangent of 45 we said was 1 times the tangent of 30, which is the square root of 3 over 3. All right, so guys, we're going to do a little bit of manipulating here. In order for me to get these two together, what do we need to have? What's our common denominator? You think of this as 1 over 1. Yeah. So we're going to write this guy as 3 over 3 plus the square root of 3 over 3. So this is going to be 3 plus the square root of 3 all over. Right? We can't add 3 and the square root of 3. They're not like terms, so we just leave it as 3 plus the square root of 3. Okay, let's do the same thing for the bottom. This is 1 minus the square root of 3 over 3. And I'm going to think of this 1 again as 1 over 1. So what's our common denominator one more time? Still 3. So this is 3 over 3 minus the square root of 3 over 3. And I'm just going to write this as 3 minus the square root of 3 all over 3. Okay, so I'm going to just slide this over. Remember what we're doing here. We're dividing fractions. And remember how we divide fractions? We take the first fraction and we multiply by the reciprocal of which one? The denominator, right? So this here is going to be 3 plus the square root of 3 over 3 times, we're going to flip this one here. All right, so that one there and that one there are going to cancel out. Well, I wish I could tell you yes, Tomas, but unfortunately they don't. I can't. So guys, when I'm canceling these, the reason I can cancel these are what we call factors. There's only one part on the bottom. When my expression either on the top or the bottom has individual terms, I can't cancel like individual pieces one at a time. I have to cancel out something that can be factored out of everything. I don't know who came up with this rule, but somebody came up with this rule, and everybody who's done some advanced math has hated this rule ever since they came up with it. And that rule is we should not have square roots on the bottom. That's why when we have like something like 1 over the square root of 2, we'd write it as the square root of 2 over 2, we'd rationalize it. Okay, I don't know why they do it, but for whatever reason they do it. So we have to figure out how can I get rid of anything that has a square root on the bottom. When we only have one term, when we have like, say, the square root of 3 or the square root of 5, you just multiply this by the same thing. But when you have two terms, like what we have on the bottom here, we have 3 minus the square root of 3, there's a little bit more work involved. And I'm going to show you how we're going to do that. What we're going to do is we're going to multiply by something called the conjugate. The conjugate just says, look at this thing right here, rewrite it again, but whatever sign you have here, change it. So if this is a minus, do it the same thing, but with a plus. And whatever you do to the bottom, you got to do the same exact thing to the top. So notice what I'm putting on the top, the same exact thing I have on the bottom. I don't do the conjugate with the top. I just, whatever it is with the bottom, put it both on the top and the bottom. Okay, guys, Monday when we were in class, we had this rule, this factoring rule, and it was a squared minus b squared is a minus b times a plus b. Remember this? We did this on Monday afternoon. And the reason why I want to pull this thing up again is if this piece here and this piece here are the same, except one of them is minus and one of them is plus, after you multiply everything out, what you're going to end up with is a squared minus b squared. I want you to look at what I got right here, and I want you all to look what we got right here. Does this part that have in the green box kind of look like this one? Okay, what's my a then? And what is b? Square root of 3. Okay, so if you know that, then my question to you, what's a squared? What happens when you square 3? 9. What's b squared? Just 3. So I know on the bottom, after you multiply all that stuff out, and you can do it by hand if you want to, but I know at the end I'm going to end up with 9 minus 3 because it's going to be a squared minus b squared. Now, unfortunately, we got to do the top. So let's do the top. We're just going to go one piece at a time. What's 3 times 3? 9. Okay. 3 times the square root of 3, guys, we're not going to make it difficult. We're going to write it just like that. 3 square roots of 3. We cannot actually put them together because one has a square root and one doesn't. Okay. Then we're going to do the same thing here. The square root of 3 times 3 is actually going to give me exactly the same thing. 3 square roots of 3. And then the square root of 3 times the square root of 3 is going to give me the square root of 9. Now we can start simplifying. On the bottom, what's 9 minus 3? There we go. Okay. On the top, these two here, y'all, are going to combine together. 3 square roots of 3 plus another 3 square roots of 3. All you're doing is combining the parts in front. 6 square roots of 3. Okay, the square root part doesn't change. It stays the square root of 3. What do you know the square root of 9 is equal to? 3. So 9 plus 3 is 12, right? Okay. One last step. 6 goes into 6 one time, and 6 goes into 12 how many times? 2. This 6, guys, I can't just cancel it with one part. It has to be able to be divided into both. If it helps, you can write it like this. I'm factoring out a 6 out of both of them, and then I'm canceling with those 6s, and that's what I'm ending up with. So remember, when I'm going to cancel something, it has to be an entire factor. It has to be able to be divided into every single piece. So I'm going to make this up. If that number there was not a 12, if it was something that I couldn't divide by 6, I couldn't just do that. I can't do it in one part and not the other. It's like if I came in here one day And we got 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of y'all, and if I came in here with 8 Snickers, that's what's going to happen. Somebody ain't getting one, right? Huh? Somebody can still want to have, but you're not everybody's going to get the same piece, right? And everybody's, I got to share, and everybody else don't get. Yeah, you know. So if you're going to do it, it has to be done with all of them, right? All right. Now, that part, this one here, I'm going to tell you right now, and I'm not telling anything you don't know, was more complicated than the other two that we did, right? Right? Why? Because we had to simplify that whole nonsense with the square roots on the bottom part. Okay. So guys, I'm just telling you, when you again, the reason why I did it this way is traditionally, whoever came up with this rule saying, if you got square roots in the bottom, you gotta get rid of them. When you have those two terms, that's when I have to do that conjugate rule. If it's just one piece, it's easy to do. But when I have two pieces, I got to go through all that nonsense there. Okay. So I hope I'm going to check your homework a little bit, but I hope you don't have too many where you've got to do that. Maybe one is probably good enough, but hopefully not more than one because it is time consuming, right? All right. So let's take a look, see what else we got here. Okay. Take a look at the next one. The sine of negative pi over 12. Okay. I'm going to try to do the same thing we did before. First thing I'm going to do, y'all, is over here on the side, and I'm just doing this over here on the side. This is kind of like my scratch work. Negative pi over 12. I want to convert this back to degrees. Anybody remember what I multiplied by? 180 over pi, right? Again, the reason why I do it this way, y'all. Let's see. 12 went into 180 15 times. So this is going to give me a negative 15 degrees. Okay? Because I got that negative there. So the reason why I'm converting these back into degrees is, and let me come back over here. The reason why I'm converting back these into degrees is, remember what we're going to do. We're going to try to use the ideas of, can I come up with a negative 15 using numbers like 30, 45, 60? And if I have those, instead of the degrees, if I have those as pi, like pi over 6, pi over 4, pi over 3, it's kind of hard for me to say, how can I come up with a negative pi over 12 using pi over 4s, pi's over 6s, pi's over 3s? And it's much easier for me to do it using nice whole numbers like 30, 45, and 60. Does that make sense? Okay. How could we come up with negative 15 using 30, 45, 60? Yeah. Sine of 30 minus 45. Okay. So guys, what I'm going to do here, and I'm just zooming out a little bit. I know I'm zooming out a lot, but I'll come back and I'll fix it in a second. Here is my sine of 30 minus 45, right? This is my u. This is my v. So I'm just going to write it out. I'm just going to write this formula using the numbers that we got. We have the sine of u, sine of 30, cosine of 45, minus cosine of 30, and sine of 45. So far, are we good on how we're getting that stuff? Okay. So I know, guys, I'm zooming out a whole lot, but I just want to make sure that we can see everything. And I'll do it this way so you can see it a little bit better. Okay. And let's start doing it to it. Anybody know what sine of 30 is? 1/2. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And sine of 45 is square root of 2 over 2. Okay. So now that we have that, then I can zoom in a little bit better. And we can see what we got. This should be square root of 2 minus square root of 6 all over what? Anybody know what our denominator is going to be? 4. Right? That's going to give me a 4. That's going to give me a 4. And we came over there. John, are we doing okay? Huh? Okay. Oh, let me come back when you're done. No, you still right. It's okay. Okay. Yes, sir. You got it. Okay. So guys, let's take a look at number 5. And let's take a look at how number 5 is written. It says sine of 65 cosine 20 minus cosine 65 sine 20. So first thing I'm going to do here, y'all, I'm going to think of this as my u and this is my v. This is my u, this is my v. So look what we have. We have the sine of u, cosine of v, minus the cosine of u and the sine of u, right? And all I'm really trying to do here is come back to the identities that we have and do a little stare and compare and say, okay, out of these here, which one does, it's all the way down there. I know I'm zooming out a whole lot, but this guy right here, what does this one look most like when you come back and you look at what you got over here? Does it look more like the sine of u plus v or the sine of u minus v? U minus v, right? It looks a lot more like, oops, it looks a lot more like this one right here, sine of u minus v. So since this here is the same thing as the sine of u minus v, and we said our u is 65 and our cosine, and our v is 20, this should be the same thing as the sine of 65 minus 20. What is 65 minus 20? 45. What's the sine of 45 degrees? Scroll back if you need to, guys. And you are done. Right? No? I'm sorry? That's because that's what I got in my formulas up here, right? So if I look at my formulas, what are they all? It could be any letter. X and Y, they're using U and V. They can use A and B, right? Why? No. Oh, you're saying they're too similar. They look too much the same. That's what you're saying. Yeah. Yeah, I know. Mine too. Look at when I did this problem right here. If you look at this piece, here we go. I need to do a little bit better like that. But yeah, that's exactly what it is we're doing. Okay. Guys, let me ask you a question. Let's take a look here at number 6. If I was sitting where you're sitting, what do you think my first step would be? Anytime we've had something with pi's over whatever, what's the first thing I've done? Change it to degrees. So what are the two values that we're dealing with? 7 pi over what? And what's the other one we got? Okay, let's do it to it. All right, let's go like this. 7 pi over 9 times, anybody remember? There you go. And I could have stayed home today. Okay, so let's get rid of these pi's. Boom. 9 goes into 180. 20 times. And 7 times 20? 140. Okay. And we're going to do this second time. Pi over 9 times 180 over pi again. And this pi here and that pi there are going to go away. And 9 goes into 180. 20 times. Oops. So we got our two values in terms of angles now, right? 140 and 20. Okay, so let's do this. We're going to scroll back this way. Okay, and I'm going to rewrite this like this. We're going to say this is the tangent of 140 minus the tangent of 20 divided by 1 plus the tangent of 140, and the tangent of 20. So far, we've been on how we got to where we are. And again, all we've done so far, guys, is just change those radians, those values in radians to degrees. Okay, so now what I want to do, I'm going to do a little stare and compare. I want you to look at what we have on the top. What's the operation I have down here? Subtraction. And then right here we have an addition, right? And I know I'm using the tangent, so I'm going to scroll back over here. This one right here, tangent of u minus v. Okay, so we're going to come back here, and we said this here should be the same thing as the tangent of tangent of 140 minus 20. And what is 140 minus 20? 120 degrees, right? And guys, remember how we filled out that radial chart at the beginning of class today? We're going to come back over here. We're going to say, where's that chart? We're looking at 120. What is the tangent at 120? Negative square root of 3. And that was why I wanted us to fill out that chart. Because now that I have that chart, that's kind of like my cheat sheet, right? I'm going to be able to use that chart every single time. So guys, remember, when you're taking a quiz, can you use the chart? Of course you can. It's right there. We just did it. When you're taking a test, can you use the chart? Of course you can. That's why we did it. It's right there. When you're doing a class assignment at home, you got to use it. Can you use it? Of course you can. It's right there. That's why we did it, right? So to me, that chart's going to be coming. It's going to come in super helpful in doing some of these problems. Okay. All right. You guys doing okay so far? Y'all need a break, or are we good? We're good? Okay. All right, let's take a look here. So number 7 says, let's find the exact value of the cosine of alpha minus beta. And it says the sine of alpha is negative 2/5 when alpha is in quadrant 4. And the tangent of beta is negative 12/5 when beta is in quadrant 2. Okay, so guys, if I was sitting where you're sitting, this would be my approach in doing this problem. I would look at this picture right here. Remember what quadrant we're in for the first part. What quadrant are we in? Yeah, we're in quadrant 4, right? So in quadrant 4, I know that my y value is going to be negative, right? And we have our radius, but we don't know what the x value is, right? So remember the way we're going to use our Pythagorean theorem here, we're going to say x squared plus y squared equals r squared. So x squared plus, my y here is actually a negative 2 squared equals my radius, which is 5 squared. What's the negative 2 when you square it anyway? Positive 4. 5 squared is 25. So when I subtract 4 on both sides, 25 minus 4, 21. And then we got to take the square root. Is the square root going to be positive or negative? We're in quadrant 4. So in quadrant 4, it's going to be positive, right? This here, y'all, should be the square root of 21, okay? All right, and I would do the same thing over here. I would look at this problem and say, look, you know what? I don't know right now. I don't know what my radius is in this picture, but since I am in quadrant 2, I know that my x value really should be a negative 5, right? Because I'm in the second quadrant, so I know that the distance is positive 5, but the value there is going to be negative 5. And I would do the same thing we did a little while ago. I'd go x squared plus y squared equals r squared. So my x is negative 5 squared. Y would be 12 squared equals the radius squared. What's negative 5 when I square it? 25. 12 when we squared? Anybody know? 144. Good. And anybody know what 25 and 144 is? 169. Okay. Now, guys, now we got to take the square root of 169. Anybody know what number that is? 13. Okay. So you might say, Omar, why did you go through all of that nonsense right now in finding out these pictures? I'll tell you why. The reason being, look at what it is we're trying to find. Yeah, the question is asking us for what is the cosine of alpha minus beta. And I'm going to say, you know what I'm going to do here? I'm going to use my cosine of a difference formula. So I'm going to scroll back up here to the top. Here we go. The cosine of a difference says it's going to be the cosine of the first, cosine of the second, plus the sine of the first and the sine of the second. So it should be cosine u, cosine b, sine u, sine b. So let me come back over here. This should be the cosine of alpha, cosine of beta. Oh man, I already forgot. Was it minus or was it plus? Plus. Plus sine of alpha, sine of beta. Okay. You can. You can definitely use it. I'm not gonna tell you anything. So let's take a look here. Cosine of alpha, cosine of beta. So guys, here's my alpha. Remember what the cosine is. It's the adjacent over the hypotenuse. Square root of 21 over 5. Okay. Cosine of beta is going to be the adjacent over the hypotenuse. Negative 5 over 13. So far, we're doing okay? All right. Sine of alpha. Remember what the sine of alpha is. They even gave it to us in the first part of the problem. Sine of alpha was negative 2/5. Anybody know what the sine of beta is? Opposite over hypotenuse. What's the opposite right here in this bottom picture? Opposite of this angle. 12 over, there you go. Okay, so now that we have that, I'm sorry, go ahead. Yeah, we're multiplying, right? We're multiplying. Okay, guys, let me ask you a question. I know there's stuff that'll cancel, but let me ask you a question. Aren't those numbers on the bottom the same? Okay, so the bottom number, we already have a common denominator. This is right at a 65, because 5 times 13 is going to give me 65. Now, on the top, this is going to be a negative 5, square root of 21. And on the top over here, this is going to be a minus 24. Right? Tell me, John, what's up? Uh-huh. Sine is y over r. Yeah, it's the opposite over the hypotenuse. See, if you look up here, John, and let me see if I can do a little bit of this here. Here we go. So remember, the sine is the opposite over the hypotenuse, right? Does that make sense? Yeah. And the cosine is the adjacent over the hypotenuse, right? You do what now? Negative 40? But I'm sorry, do what now though? You're talking about, you're converting that to a decimal, and it would be 0.40, right? Yeah. Yeah, and remember, really think about it this way. Remember, the trig functions are defined as ratios, right? Opposite over this. That's why you want to keep it that way, right? Because it's going to make it much easier to do. Okay, so guys, we got a few more problems to do. I'm going to tell you right now, we're going to skip number 10, and I'm going to make sure that you don't have anything like this in your homework. So I'm going to get rid of number 10, and so we only got 3 more problems to go, and we'll be done here, okay? So look, we're going to do some more verifying identities. So look what we have here. We have the sine of x minus 3 pi over 2. Okay, so guys, obviously here, I'm going to use this formula. Sine of u minus v, because it says x minus 3 pi over 2, right? Okay, so I'm going to use the formula, and I'm going to come back and I'm going to say, okay, what's the sine of u minus v? Let me make sure I know it. Sine of u minus v is sine of u cosine v minus cosine u sine v. Okay, so really all I'm going to do here, y'all, is just use that in doing my problem. Sine u cosine v. So this is going to be sine of x cosine of 3 pi over 2 minus, it should be cosine of x sine of 3 pi over 2, right? Okay, so guys, a couple things we could do. One thing we've been doing so far is anytime I had a radians, we converted automatically to degrees. But in chapter 4, when we were graphing our trig functions, we had to know the sign of 0, pi over 2, pi, 3 pi over 2, and 2 pi. So 3 pi over 2 is 270 degrees, right? When we talk about the unit circle, we talk about the unit circle, we said this is 0, 90 degrees, 180, down here by my toes, 270, right? My fingertips. So think about, here's the xy axis, right? And when we're down here, right, what is, and think about the unit circle. So my arm is a distance of 1, right? 1 foot, 1 yard, 1 feet, whatever you want to call it. But if I'm down here, right, the bottom of the y-axis, and the distance from here to here is 1, what were the coordinates of this point down here? But every coordinate has 0, -1, right? So the cosine involves what value, the x or the y? Cosine, again, the x, right? What's the cosine of 3 pi over 2? You said the coordinates at this point were 0 and -1. What's the cosine of 3 pi over 2 then? It's the x value. 0, right? The cosine down here, guys, is going to be 0. So if the cosine of 3 pi over 2, if this guy here is 0, 0 times the sine of x, it's going to go away. Right? Because 0 times anything is what? 0, right? Okay. What are the coordinates of the point down here again? 0 and -1. The sine is the y value. So the sine of 3 pi over 2 is -1. What is a negative cosine of x times a -1? Positive cosine of x. And what do the directions ask me to do? To show that this piece here is equal to that piece. All right. Yes. Right? Because the sine of 3 pi over 2 is -1, right? And -1 times the negative cosine x is just a cosine x, right? All right. Guys, let's do the same thing for number 9. Remember when we talked about verifying identities on Monday? It said we're going to work with the more complicated side. Which side looks more complicated? The left or the right? Well, let me ask you a question. Do we have a formula for anything like this? Yeah, it's the formulas we're talking about today. Cosine of x plus y. I'm going to come back over here, and I'm going to use this formula right here. Cosine of u plus b, cosine of u, cosine of v, minus sine u, sine v. So the cosine of x plus y will be cosine x, cosine y, minus sine x, sine y. So all we've done here, y'all, is break up that piece. Okay? Let's do the same thing over here. Cosine of x minus y. So I'm going to come back. I'm going to scroll back so I can look at my formula. Is cosine of x, cosine of y, plus sine of x, sine of y. Real similar. Now, the only thing I'm going to do, I'm going to put that in parentheses because I want you to notice what we had in the middle. We got a minus sign. And a minus sign means we're going to subtract. So these two pieces, I'm going to leave them alone. I'm going to write this as the cosine of x, cosine of y, minus the sine of x, sine of y. And I'm going to start distributing this negative 1. So remember what that negative 1 did? It changed the sign here, and it changed the sign there. So question, what's going to happen with this cosine x, cosine y, and this cosine x, cosine y? But look at the signs in front of them. The sign here is positive. The sign here is negative. What's going to happen to them? Cancel out, right? What about a negative sine x, sine y, and another negative sine x, sine y? There you go. Negative 2 sine x, sine y. And look what we had on that side. How did we cancel the cosines? Okay, so good question. This one here has a positive sign, and this one here is a negative sign, right? So that's why those are canceling. You can think of this here as a negative 1, and that's another negative 1, right? So negative 1 minus, or negative 1 minus 1 is negative 2? Better? Good, good. Right? All right. So guys, we got one more here out of 5.2, number 11. So we have the sine of x plus y. Okay, so I'm going to zoom in a little bit so I can see a little bit better. Sine of x plus y. So let's come back and let's see if we can use the formula for sine of x plus y. So I'm going to scroll back over here. Sine of x plus y is the top one. So yeah, this is sine x cosine y plus cosine x sine y. Okay. And let me just make sure that I copied it down right. Yes, it was a plus. Okay. All of that is over what? cosine x, cosine y, right? Okay, so I'm going to go like this. Cosine x, cosine y. Okay. I want you to notice what we have here. We have a combined fraction. We have this piece plus this piece all over the same denominator. All that means, y'all, is that we can rewrite this as what we call separate fractions. All we've done now is separate the fractions. This piece over the bottom, that piece over the bottom. Let me ask you a question. Oh yeah, sorry. That was my bad. It was what? Cosine y? Thank you. Okay, let's look at that first fraction that I put a box around. Anything there going to cancel out? Anything on the top exactly the same as on the bottom? Cosine y, okay? So that means that we are left with sine x over cosine x, okay? Look at the second fraction. Anything over here exactly the same on the top as it is in the bottom is going to cancel out. Cosine x. What are we left with then? Okay. Guys, we have one of these things called quotient identity. What trig function is the same as the sine divided by the cosine? There you go. This is the tangent of x plus, no, still tangent, because it's still sine over cosine, over tangent of y. And I'm going to show you something. When we come back over here, look at what we had on the right side. Tangent of x plus tangent of y. You got it.
Still has magic where it's like you don't know what the hell's going on when you get to this end. It's like, wait, what?
So think about it this way. Remember what's my objective here? My objective is to show that this piece, oops, my objective, can't even talk. My objective is to show that this piece here is going to be the same as that piece there, right? So I'm keeping in mind that in the box is what I'm trying to get to, right? But what did I do first? We just said, look, we got a formula for this. Well, let's apply it, right? Because we have a formula for this. Remember, all of 5.2 is using, well, here we go, using those formulas right there, right?
I understand what you did. It's just a sensation, I guess, when you get a magician that shows you a card in the trick, and your mind is blown that you got the same card that was from the beginning after you did all this magic stuff and it shows you the same card. I mean, so it's just-
Yeah,
it's
no, I
like
know.
emotion right there.
Yeah, I know what you mean. And guys, so remember these problems. Look, hold on. Let me stop recording because we are done with 5.2. So let me go ahead and